Good morning, my name is John Wong, and today I will talk to you about special right triangles. As you know, in a right triangle where there's 90 degrees, if two sides are equal, it's an isosceles triangle, and of course this is 45 degrees, both sides. Then whatever the length of the side is, the hypotenuse is always the length of the side times radical 2. It saves us a lot of work without having to use the Pythagorean theorem, which will give us the same result if we have square the first plus square the second. It will be the square of the hypotenuse. Now, what I want to do is to show you that if you give students a number, then it's easy to get the hypotenuse. Just multiply by radical 2. And if you give the student any number with a radical 2, they can find out the side just by stripping away the radical 2. Now the difficulty comes in when we don't have a radical 2 here. What if we have a 6? Then we have to teach them that in order to go from the side to the hypotenuse, we multiply by radical 2. If you want to go backwards, you have to divide by radical 2. But this needs to be rationalized. So therefore, you have to multiply by radical 2 in the denominator and a radical 2 in the numerator, so that you can get 6 radical 2, and this will rationalize radical 2, give you a whole number 2. And if you reduce this, this will give you 3 radical 2. So, it's a little bit complicated, so I want to show you a shortcut. And the shortcut is this. Given this number, in order to get the side, all you have to do is divide it by 2 and multiply by radical 2. And of course this is 3 radical 2. The same answer you would get if you had to go through the complicated explanation. And it always works out that way. Whatever number you give me, okay, even a 5, then I'm going to divide it by 2 and then multiply by radical 2. There's really no work needs to be shown, because basically that's why it's called special. When you have this kind of triangle, special right triangle, it's always relative. Whatever you have here, this is always divided by 2 times radical 2. And you can show and prove any number you give me, I will be able to get this side by taking the hypotenuse and divide it by 2. So let's say we have x, then this will be x divided by 2 times radical 2. And that would be the solution. Thank you very much. Good morning, my name is John Wong, and today I am going to explain to you about the special right triangle when it's a 30, 60, 90 triangle. Now this is the general formula, so to speak. Whatever the short side is, the hypotenuse is always 2 times that, and the medium side is always the short side multiplied by radical 3. So for an example, if you have a 5-inch, then the hypotenuse 10, and the medium size 5 radical 3. And if you are given the medium side, let's say 11 radical 3, then you can easily get the short side by stripping away the radical 3 make it 11, and this will be 22. However, it becomes more difficult though if you don't have radical 3 here. What if it's 111? Now, how do we find the short side? Well, we just got to go the opposite direction. When you go from the short side to the medium, you multiply the short side by radical 3. So if you want to go back, then you have to divide it by radical 3. But then you have to rationalize this by multiplying with radical 3, denominator, radical 3, numerator. This is a 1, so when you multiply, it's equivalent. Radical 3 times radical 3 is 3. So this will give you 111 radical 3 over 3. And of course, we know 111 is divisible by 3, and so the answer is 37 radical 3. So that's the answer, 37 radical 3. And of course, this will be 74 radical 3. Now, instead of going through all that, my shortcut version is basically to take a number, okay, any number, and divide it by 3 and multiply by radical 3. That's right. Whatever number you give me, okay, x, I'm just going to divide by 3 and multiply by radical 3. That would be the shortcut, because that's what it comes down to. Okay, so if you take any number, perhaps 27, then this will be 27 divided by 3 radical 3. Alright, which is 9 radical 3.